We're going to continue our discussion of section 2.4 about linear equations, and we're going to focus on looking at some parallel and perpendicular lines and how we work with those and their equations. Let's look at these two parallel lines and see what happens in terms of their slopes. So if we look at our first line, we notice that it has a slope of 3/2. If I look at the second line, it also has a slope of 3/2. Now, if we understand that slope is the steepness of the line and parallel lines are not supposed to intersect, then it would only make sense that they should have the same amount of steepness. Otherwise, they're going to eventually meet each other. So the first concept that we need to make sure we understand is that parallel lines will always have the same slope. Now let's look at some examples of perpendicular lines. So here we have two lines that are perpendicular, and let's look at their slopes. So let's look at our blue line here and calculate what our slope would be. So let's pick 2 points. Let's pick the point here where these two lines are intersecting, and then let's pick this point here on the y-axis, and let's count our rise and our run. Now, notice that we're counting by twos, so if we count up, we go 2, 4, 6, 8. Up 8, over 2, 4. So my slope would be 8 over 4, which would be 2. Now let's look at the red line and do the same thing. So we'll pick a point here, again, where they're intersecting, and then let's pick this point on the y-axis, where our red line is touching the y-axis. So let's count our slope off. So starting here, we're going to count up 2, and then over 2, 4. So my slope for the red line is up 2 and over 4, but we did go 4 to the left, so it'd be -4. So that gives me a slope of -1/2. Now, if I look at the two slopes, there is a relationship between those. Notice that if I rewrite my slope of my first line as 2 over 1, that the first thing I would notice is that those two slopes are reciprocals of each other. Then I also notice that they have opposite signs, and that's the relationship between parallel lines and their slopes. When you have lines that are parallel, they have slopes that are opposite reciprocals of each other. Now what we're going to do is apply that to writing some equations of lines. So let's look at this first example. We want to write the equation of the line that passes through the point 3, -5 and is parallel to y equals -2x plus 7. Well, as I previously stated, remember that we need to know a point and a slope. Well, we have our point, but we need to get our slope. Well, recalling what we just said about parallel lines, we know that lines that are parallel have to have the same slope. So if I'm parallel to y equals -2x plus 7, for that equation, my m, or my slope, is -2. So the equation of the line I'm trying to write must also have a slope that's -2. Now I'm going to use my point slope form. Y minus y1, which would be minus -5, so plus 5, would equal m, -2, x minus x1, which would be 3. Now I'm going to go ahead and distribute and get -2x plus 6 and get the y by itself by subtracting 5. And I get y equals -2x plus 1. So the line y equals -2x plus 1 and the original line of y equals -2x plus 7 are parallel to each other, and notice that they have the same slope. But this line, my second line, will pass through the point 3, -5, or Yes, 3, negative 5. Let's look at another example. Here I want to write the equation of the line, this time that's perpendicular to negative 2/3 x minus 1, and pass through the point 6, 5. So we have our point, but we need our slope. Well, the line they gave me has a slope that's negative 2/3. And as we just discussed, lines that are perpendicular have slopes that are opposite reciprocals of each other. So the slope of the line I want to write would be a positive 3/2. And let's go ahead and use our point slope form. Y minus 5 would be equal to m 3/2 x minus my x point, which would be 6. So I'm going to go ahead and distribute 3/2 x. 3/2 times 6 would be 9. And then we'll add 5 to both sides so that we can get y by itself. And we have 3/2 x minus 4. So that's the line that would be perpendicular to that line. In our last example, we're going back to a problem where we want to be parallel, but notice that this time my original line is not in y equals mx plus b form. So we know our point is 3, 4, but we're going to have to get our slope. Well, I'm going to have to take this equation and get it in y equals mx plus b form so that I can find my slope. So let's subtract 2x, get negative 5y equals negative 2x plus 7. Then we'll divide by negative 5. And y would equal, since negative 2 doesn't divide evenly by negative 5, we'll just leave it as positive 2/5 x. And then 7 divided by negative 5 doesn't divide evenly either, so we'll make it minus 7/5. So the slope of this line would be 2/5, which means I want something parallel to that, so the slope of that would also have to be 2/5. And now let's go to our form. Y minus y1 equals m x minus x1. So y minus 4 would be 2/5 x minus 6/5, just doing distributive property. Then we want to add 4 to both sides. So y would equal 2/5 x. And then let's go off to the side and take negative 6/5 and add 4 over 1. But that would be negative 6/5 plus 20/5, which would be 14/5. And so there's my equation that would be parallel to the line they gave me and pass through the point 3, 4.